So in the last video we did R1 and R2, and in today's video we're going to have a look at P1 and P2. I can generate information to solve sequence problems in non-mathematical contexts. Jermaine has £34 and spends £7 per week. After how many weeks will he run out of money? So as you can see, Jermaine has £34 and he spends £7 per week. So we're going to create a sequence and our beginning point is going to be 34. Once we've done that, we can see that he's spending £7. Spending means that we're subtracting, so we're going to write down we're subtracting 7. Now, we need to find the second number in our sequence, so we're going to do 34 subtract by 7, which is going to be 27. Once we've done that, we can keep on subtracting 7, and we get the following. Because we're looking for how many weeks he's going to run out of money, we're going to be particularly interested in when he has a negative amount. So as you can see here, he has a negative amount when he's got -1. Then we're going to label after how many weeks that's going to occur. So for the first week, he's going to have 27. Second week, he's going to have 20. Third week, he's going to have 13. Fourth week, he's going to have 6. And in the fifth week, he has -1. So we can see here, we're not going to consider the first number because it's the initial amount that he has. So therefore, Jermaine runs out of money after 5 weeks. Because this is a problem-solving type of question, do not forget to include your sentences at the end. Here's a question for you to try. Pause the video here. Here's the solutions. Make sure that you self-assess your work. So as you can see, once we've created our sequence, we can see that Jasmine runs out of money after the 4th week because she's got -£2 in her account. So we're going to write down the sentence. She runs out of money after 4 weeks. Let's have a look at a different type of question. Savannah spends £4 per week. Kitali spends £6 per week. After they both spend each week, which amount will they both spend after how many weeks? So as you can see, Savannah spends £4 per week. So we're going to write a sequence for Savannah for 4, 8, 12, 16, 20, and so on. We can see Kitali spends £6 per week. So we're going to write a sequence for Kitali, starting with 6, 12, 18, 24, and so on. Once we've done that, referring back to the question, we can see we're asked to find which amount that they both spend. So if we look at both sequences, we need to look at which number they have in common. So as you can see, the number 12 is in common in both the sequences. So we're going to write a sentence. They will both spend £12. Referring back to the question again, as we have another question, it asks us to find after how many weeks. As you can see, Savannah spends after 3 weeks the £12, and in Kitali's case, she spends the £12 after 2 weeks. Now, you will notice for this type of question, we have included the initial amount, and the reason why is because it is part of the sequence. We do not ignore it. So this is very different to the question that we did before, where we did ignore the initial amount. Here's a question for you to try. Pause the video here. Here's the solutions. Make sure that you self-assess your work. So as you can see, we created a sequence for both Liam and Emmanuel. In Liam's case, he spends the amount in 4 weeks. And in Emmanuel's case, he spends the amount in 4 weeks. As you can see, they both spend £100 together. So that means we write a sentence to describe that they both spend the money after 4 weeks. And that's the end of P1. And we are now going to move on to P2. I can generate information to solve sequence problems in unfamiliar mathematical contexts. Find a sequence that has both 14 and 26 in it. Write down the rule of the sequence you created. So for this type of question, we need to create a sequence that has both the numbers 14 and 26 in the sequence. Then once we've done that, we then need to write down the rule of the sequence that we have created as well. So I'm going to create a sequence that has both these numbers, 14 and 26. So we've got a possible solution here. So we've got 14, 26, 38, 50, and 62. So the rule of my sequence that I've created is that we can add 12 each time to get from one term to the other term. As long as the numbers 14 and 26, as you can see, appears in the sequence, that is a possible solution. Now let's have a look at a different possible solution that we can also get. As we can see, we've got different sequences that we can create. So another possible solution is the sequence as follows: 10, 14, 16, 20, 22, and 26. So as you can see, the numbers both 14 and 26 appear in my sequence as highlighted. See if you can find the rule of the sequence that I have created. So the answer would have been that we are adding 4, then adding 2, adding 4, then adding 2, and repeating this as we are going along. So as you can see in this sequence, once again, we can see the numbers 14 and 26 appearing once again. Now, if we compare both the solutions that we got, we can see that they're two different types of sequences, but they still have the numbers 14 and 26 in the sequence. So as you can see, you can get so many different sequences, and really what we're trying to be is as creative as we possibly can. Here's a question for you to try. Now, before you pause the video, as an extension, try and see if you can find 10 different sequences. Be as creative as you possibly can by finding so many different rules to the sequences that you've created. Here's the solutions. Make sure that you self-assess your work. So as you can see, there are two solutions that I've come up with. For my first sequence, I'm subtracting 4. For my second sequence, I'm subtracting 8. Bear in mind, any solution is okay as long as both -3 and -19 appear in your sequence that you've created. Let's have a look at a different type of question. A sequence is generated by multiplying the previous term by 2 and then adding 3. What is the first term if the third term is 53? So as you can see, we're multiplying by 2 and then we're adding 3. So we can write this down as the first thing we do is multiply by 2, then we add 3. This is the case only if we're going forwards. So if we're going forwards, the first thing we do is multiply by 2 and then we add 3. But we don't want to go forwards. We want to go backwards. As you can see, we're asked to find the first term if the third term is 53. So we want to go backwards. So what we're going to do is we need to find what the first thing and the second thing would be if we're going backwards. Try and see if you can find out what the first thing and the second thing would be if we're going backwards. To help you, here's a thinking point. So let's say step 1 was putting your socks on and step 2 was putting your shoes on. Try and see if you can find out what would happen if we were to go backwards. Here's the solutions. Try and see if you got what I did. So we should have got step 1 is taking off your shoes and step 2 is taking off your socks. So as you can see, step 1 became step 2 and step 2 became step 1. Now, again, we can also see that instead of putting, we are now taking off. So we're also taking the opposite of that as well. Let's now refer back to the question that we were doing before. So here we were multiplying by 2 and then we were adding 3. So the first thing we do is we keep the 3 and the second thing we do is we keep the 2. Now we need to figure out next what the operation would be in front of the 3 and what the operation would be in front of the 2. So as you can see, we're going to be subtracting, as subtracting is the opposite of adding and multiplying is the opposite of dividing. So we're going to be dividing by 2. So when we are adding 3, the opposite would be subtracting 3. And when we're multiplying by 2, we're going to be dividing by 2. So we need to also take the opposite of that as well. Now we've got our first, second and third term written. And in the question says the third term is 53. Now remember, term just means the position in our actual sequence. So the third term just means the third position in our sequence. So where it says the third term, we're going to fill that space with the number 53. Once we've done that, we want to find the first term, remember. Are we going to be using the forwards rule or the backwards rule to find the second and the first term? So we're going to use the backwards rule. And the reason why is because we're going in the opposite direction in our sequence and we're not progressing in the sequence. So we need to use the backwards rule. So we can easily use the backwards rule to find the second term by doing 53, subtract 3, divided by 2, which is going to give us the number 25. Once we've done that, we can easily find the first term by doing 25, subtract 3, divided by 2, which is going to give us the number 11. Once we've done that, remember to refer back to the question. It asks us to find the first term. So we found the first term, which is 11, but we must write down a sentence explaining that the first term is equal to 11. And that's it for the question. So reread what we've done before moving on. Here's a scaffolded question for you to try. So as you can see, there are keywords in this question highlighted. There are also some visual cues to support you, and you need to find the first, second, and third term. Now, as an extension, see if you can also find the first term. Pause the video here. Here's the solutions. Make sure that you self-assess your work. So as you can see, when we're going forwards, we're multiplying by 2, then adding 8. If we're going backwards, we'd expect to subtract 8, then divide by 2. So we're going to be using the backwards rule as we're going backwards in the sequence. So the third term here is going to be 48. And to find the second term, we need to subtract 8, then divide by 2, which gives us 20. And then we need to subtract 8 once again and divide by 2. And that means our first term here is going to be 6. Remember to write your sentence as well. So to describe the sentence, we're going to write down the second term is 20 and the first term is 6. Here's another question for you to try. You will notice that there's no support for this question available. Pause the video here. Here's the solutions. Make sure that you self-assess your work. So as you can see, we are multiplying our previous term by 3, then adding 13, and our third term is 358. So when we're going forwards, we're multiplying by 3, then adding 13. And if we're going backwards, we're going to subtract 13, then divide by 3. So as you can see, our third term here is 358. To find our second term, we need to do 358, subtract 13, then divide by 3, which gives us 115 as we're going backwards. Once we've found the second term, we can then find the first term by doing 115, subtract 13, then divide by 3, which gives us 34. So the first term is 34. And that's the end of P2. So in today's video, we covered both P1 and P2. Here's a beat the clock. So you've got 2 questions, one for P1 and one for P2. So option 1, £6 on day 1, £12 on day 2, £18 on day 3, and so on for 5 days. Option 2, £2 on day 1, £4 on day 2, £8 on day 3, and so on for 5 days. Which will get the most amount of money after 5 days? For question number 2, a sequence is generated by multiplying the previous term by 6 and then adding 2. What is the first term if the third term is 358? Now remember, you're doing problem solving questions, so don't forget to include your sentences as well. For this type of questions, do spend about 8 minutes on this. Using a timer, time yourself and pause the video here. Here's the solutions. Make sure that you self-assess your work. So as you can see, in both option 1 and 2, we need to go up to 5 days. So for option 1, we can see that we've got 30 after 5 days. And for option number 2, we can see that if we keep going for 5 days, we've got 32 after 5 days. And we need to see which one makes the most amount of money. So we can see that option 2 leads to the most amount of money after 5 days. So we need to write a sentence for that. So last question, we can see that multiplying the previous term by 6, then adding by 10, we need to go backwards. So if we're going backwards, we need to subtract by 10 and divide by 6. So the first term would be 8, then 58, then 358. So we need to write a sentence as we're being asked to find what the first term is, and we can see the first term is 8. That's the end of today's lesson.